Okay, so today we're going to be looking at section 6.4. What we're going to be learning in this lesson is we're going to be learning how to solve or simplify different radicals. Most of you are relatively comfortable if a radical might be a square root, but we're going to be looking at how to take the fifth root, how to take things like the fourth root, various roots on our calculator, and how to do that with variables as well. And so I want to start by looking at this chart that you have at the top of your notes page here. Some of the chart is filled in for you already. What I'd like for you to focus on as you're looking at this is let's look at what we have on the left side here where it says x cubed equals 64. Now if our goal was to solve this equation for the x, the way to get the exponent, the 3, to cancel would be to take the cubic root of both sides. So you would have to take the cubic root of 64. You would also be taking the cubic root of x cubed, and that would make x equals whatever the cubic root of 64 is. Now you're going to want your calculator handy there. So if you don't have it with you, you can pause this video, go grab it, and I'm going to show you how to type in roots that are higher than a square root. Okay, what you're going to press on your calculator is you're going to press the math button. You're going to see that along the left-hand side of your calculator. Okay, once you press the math button, you should see an option. Most calculators, it's option number 4. Should look like a little cubic root symbol. Then you will just type in 64, and you'll see that the answer to that is actually 4. Okay, when you're solving roots like this, essentially what you're saying to yourself when you're trying to figure out, okay, what number, if I take the cubic root of 64, what I get, you're essentially saying to yourself, there's some number that if I were to multiply that number times itself 3 times in a row, 3 because that's our root, that the answer would give us 64, and of course we know that that's a 4. Okay. All right, so I want to look at just another example here. Let's take a look at the next row here. You can see in this example, now our exponent is a 4 instead of a 3. And so what we would do if we were solving this is we would take the fourth root of both sides. That would get just an x on that side. Of course, we need to be able to take the fourth root of 625 on our calculator. Okay, now the way that you're going to do this varies depending on how new your calculator is. If you tend to have an older calculator, what you're going to need to press first, before you even press the math button, is you're going to need to press the number 4. Okay, this actually works for new calculators and old calculators. You're going to press 4 because this is going to be the root. We call that the index, what we're wanting to take. Okay, and then you're going to press the math button, and directly underneath that cubic root function, for me, it was option 4. You're going to see option 5. It's going to look like a square root, but the index right here in this spot, it will be an x. Okay, so you want to pick that one. And since we already typed a 4 in first, it moves that 4 directly into the spot where this index is. So now it's taking the fourth root of, and you would type in then 625, and that gives us 5, which essentially means that if you were to multiply the number 5 4 times in a row, that would give you 625. Okay, so let's just talk briefly here about the different components to a radical, and we're going to look at a few scenarios here in this chart before we move into simplifying these problems. If you hear me use the term index, okay, index is referring to what your root is. Square root, the index is 2. Fifth root, the index is 5. Okay, obviously the radical symbol is this symbol right here, okay, and then the value that is underneath the radical symbol, we call that the radicand. Okay, the radicand. So I want to look at 4 different scenarios. These are your 4 situations. Anytime you're taking a root of some sort, a radical symbol, you're either taking an even root or you're taking an odd root. Okay. Now, you could be taking the even root of a positive or a negative number, or the odd root of a positive or a negative number. And I have listed here what your solutions are. Now, it's been a little while since we've talked about imaginary solutions, but I want to look at that situation first. Okay, that is actually this second row here in the table. You'll notice that when you take the even root of a negative number, your answer is actually 2 imaginary solutions. You have 0 real number solutions. Let me have you fill in an example over here. So we want to make sure that our root is even. So we're going to do the square root. Now, technically speaking, if you're doing a square root, you don't have to show the 2 here. It's assumed that that would be a 2. Okay, and I'm going to make sure that our radicand, this is the number underneath the radical, it's going to be a negative number. Okay, remember, that's when it results in those i's here. Okay, so when we're doing an even root, when you're doing an even root, this is when you're going to get 2 possible answers. Okay, so I'm going to have you make this little note to yourself. All the even roots, you have 2 answers. Okay, so that's why we always put a plus or minus in front of those. So I'm going to put a plus or minus. We know the square root of 25 is 5, but because there's a negative underneath the square root, we have to attach the I onto our answer. Okay, I'm also going to have you just kind of draw an arrow just to that second row here. This is the only scenario involving imaginary numbers. Okay, let's backpedal to the previous row here where we're taking the even root of just a positive number. So an example of that, I'm going to make our root 4. Okay, that's even. The radicand is going to be positive here, so I'm going to make that a 16. Okay, so we're looking for what number would we multiply times itself 4 times in a row that would equal the number 16. Now remember how to take the 4th root on your calculator. If you're not sure, you're going to press 4 first, then the math button, and then you're going to pick option 5 that has the little x in there, okay, and then type 16, okay, and that will give you, it's actually 2, okay, a 2 multiplied times itself 4 times in a row equals 16. However, because this is an even root, we're doing plus or minus in front, okay. Now, with the odd roots, it's not 2 solutions. There's only 1 solution. See how there's only 1 here, okay. So when you do the odd root of a positive number, we'll say the cubic root of 27. Again, you could hit the math button, option 4. We might have this memorized. The cubic root of 27 is 3. And the reason there's only 1 answer for that is because now if we're talking about multiplying something times itself an odd number of times, 3 positives will give me this positive 27. But if I made that 3 negative 3s, that's not going to equal a positive 27. That's then going to equal a negative 27. So I only have 1 possible answer for this, 3. Okay, and then if in my last scenario here, if we're doing the cubic root of negative 27, that answer is actually negative 3, okay, and only, again, 1 solution for that. Okay, so let's see how this is applied in some of these examples below here. The directions read, find the root of the number using the math button on your calculator. So we're talking about finding the root of the numerical part of your radicand. And then for the exponent, I'm going to highlight this here. We're going to divide the exponent on the variable by the root. So I'll demonstrate this for you here. Okay, so here we have an odd root. So if I'm going to do the cubic root of 64, I'm just going to use the math button on my calculator, select the cubic root, type in 64, and I get that to be a 4. Now I'm not putting a plus or minus here because this is an odd root. Now, how do I do the cubic root of r to the 6th? Well, I'm going to divide the exponent, the 6, that's on my variable, by the root, that's the 3. So I'm taking 6 divided by 3, and the exponent on the r would be a 2. That is my answer. Okay, let's try this next one here. Again, another odd root problem. Okay, so you're going to press 5. Anything higher than cubic root, you have to type the root first, math button. It's actually option number 5. You're going to take the 5th root of 32 on your calculator. That's going to come out as a 2. Now, as far as the variables go, you take the exponent on the variable, 10, divide it by the root, 5. The new exponent on the a would be 2. Taking the 5th root of b to the 5th, 5 divided by 5, my exponent on the b would be a 1, which you don't actually have to show. It's assumed it's a 1 if you don't show it there. Okay, all these problems are going to be drafted in such a way that when you divide the exponent on your variable by your root, these are going to divide out nice and evenly here. Okay, let me just mention one thing here in this next set of directions. It says when you have an even root, if it doesn't automatically, and this is a little jumbled in here, if it doesn't automatically have a plus or minus symbol in the problem, it means that it's only wanting you to identify the principal root, meaning it only wants you to give the positive answer. So I'll demonstrate that with just a few examples here below. Okay, so in example A, let's look at this one. See how there's already a plus or minus in front. So I'm just going to copy that down. I'm taking the square root. Notice when you don't see a value here in the index, you assume it's a 2. Okay, we should know the square root of 16 is 4. Okay, remember this is a 2, so the rules for taking a radical of a variable is you divide the exponent on the variable, 4, by your root, 4 divided by 2. The answer is 2, so my new exponent on the y is 2. Okay, now this one is where we're going to want to make sure that we're being a little bit careful here. When you've got a quantity that's underneath your radical. Okay, if your variable and a number are grouped together in parentheses, you're going to actually not make any changes whatsoever to what's inside these parentheses. The only thing that you're going to look at is you are just looking at what that exponent is on the outside of the parentheses. Now, I should say, if there's a negative in front, they just want you to copy that negative down. Okay, I'm leaving what's in the parentheses there. Remember, this is a square root, so I'm going to be dividing 12 by 2, and my new exponent would be 6. Okay, let's go ahead and try the next one. We'll just look at a couple more, and then we're going to go ahead and flip to the back here. Okay, I'm probably going to need my calculator on this to do the 5th root of 243. So again, you're going to press 5, the math button, option 5, type 243. I'm seeing 3 on my calculator, so I'm just going to go ahead and write 3 down here. Okay, then I'm dividing exponent by index, exponent by index. So it looks like that's going to be a to the 4th, b to the 5th. That will be my answer here. Okay, let's go ahead and take a look here at, we're going to jump over here to example F, and we'll also take a look at example I. Okay, now I picked these ones because these ones have quantities very similar to example B. Remember, if it's got a quantity, you're making no changes whatsoever to what is inside the parentheses. Okay, so on this problem, I'm going to go ahead and copy that negative sign down. I'm not making any changes to what's inside. That's going to stay y plus 7, but what's going to change is what the exponent is on that y plus 7. Now remember, my exponent on the outside is a 16. If I don't see an index, then my index is a 2. I'm going to divide 16 by 2. My answer, negative, times the quantity y plus 7 to the 8th. Okay, one more. Now, here you're going to be a little bit careful because this 64 is not actually inside the quantity. It's separate out in front. And so we need to first, on the calculator, take the 6th root of 64. Okay, the 6th root of 64 is a 2. Now, technically, in this problem, we said even roots, you put a plus or minus. But the directions are saying if there is no plus or minus symbol in the problem, it's only wanting what's called the principal root. That's just the positive answer only. So we're just going to keep that as a 2. We're going to put x squared minus 3 in parentheses, and then I'm going to go ahead and I'm going to divide the exponent on the quantity by my index here, 18 divided by 6. My new exponent is a 3. Okay, let's go ahead and flip to the back. We're going to take a look at just a couple word problems. Here you kind of see this in action in a few application problems. This is talking about the number of bicycle collisions that occur. It says the number of bicycle collisions that occur increases as the number of bicycles per intersection increases. Okay, so basically they're saying the more bicycles that are trying to cross in any given intersection, it increases the likelihood of having more collisions of bicycles. And so I think the key with any word problem that we do in algebra where we're given an equation of sorts like this, you want to be paying attention to what is the B representing in this formula. It's the number of bicycles. Here, what's the C representing? That's our Y variable. That's the number of collisions. So we can keep that in mind. I think that the two parts A and B to this problem should be relatively simple here. So let's go ahead and look at part A. Part A says, what will be the approximate number of collisions? So they are asking us to find, remember, number of collisions is C, at this intersection that has 1,000 bicycle riders per week. Okay, not 1,000 simultaneously at the same time going through this intersection, but just across the week. Notice this is defined per week here. Okay, so we're going to plug this 1,000 is going to go into our formula for the B. So simply just substitute it in there, and we just need to be comfortable using our calculator to simplify this. Okay, now there's no variables here, so we could go ahead and actually type this in straight into our calculator. Again, remember, anytime your index is higher than a 3, you're going to start by pressing 5. That's your index. Math button, option 5, and then type in 1,000 and make sure that you square that. Okay, let's see here, 1,000 squared. Okay, so we are taking the 5th root of 1,000 squared. This answer comes out to a decimal, so I'm going to go ahead and round it up to the nearest whole number. I'm going to go ahead and label it, which is what you want to do on all word problems. Provide some context there. 16 collisions is roughly what we would be looking at. Okay, so part B says if the total number of collisions reported in 1 week is 21, okay, so that is your C, estimate the number of bicycle riders that would have passed through that intersection for the week. And so now we're plugging 21 in on the left-hand side, and we're going to need to use a little bit of algebra here to try to get creative with how we can solve this equation for B. Okay, one of the first things that you're going to want to do is you're going to want to get rid of this fifth root symbol. Okay, now think about if this was a square root symbol, what we would do to get rid of that symbol, we would square both sides, right? So if this is a fifth root symbol, we're going to want to raise both sides of this equation to the fifth power. That's going to cancel out the radical symbol, but you're still left with the radicand. Okay, radicand is the value that's underneath the symbol there. Okay, so I still have the b squared. Okay, my goal is to get this solved just for b, so then to cancel out the exponent of a 2, I would then take the square root of both sides, and I would need to type into my calculator the square root of 4,084,101. Again, likely going to get a decimal. We'll go ahead and round this up to the nearest whole number. We're looking at roughly 2,021 bikes is what we would have there. Okay. All right, let's take a look at just one more problem because I think there's one similar to this on a worksheet that you're going to have here soon. It says the surface area of a sphere can be determined from the volume of the sphere using the following formula. So S stands for the surface area. I'm going to highlight that here. Okay, V is standing for the volume of the sphere. Now notice this other variable here, it's actually a number. We're going to use the pi button on our calculator there for that. The question is determine the surface area. So we're trying to find the surface area if the volume is 200 cubic inches. Okay, so this is really just going to kind of come down to, can you type this into your calculator correctly? Okay, notice that I entered the 2,000 directly in for the V, but that is squared. Okay, so we would want to choose that cubic root function on our calculator. You're going to press the math button, you're going to press option 4, and then you're just going to type in 36, the pi buttons underneath that caret key, times 200 squared. All that needs to go underneath the square root symbol. Now it is totally fine to leave your answer as a decimal. You want to label the surface area is inches squared. Okay, units are always squared when we're talking about area. Okay, let's look at the last one here. Here they're saying, what if the surface area is 215.5 square inches? Now let's see if we can go backwards and find what the volume is. Okay, so now we're going to try to peel things away to get this V by itself. The first thing we want to remove is this big cubic root symbol. Okay, so what you're going to do first, get that to cancel. You're going to take the cubic root of both sides. Okay, there's going to be a really big number on the left side here to start out with when you cube 215.5. Okay, so now I have 36 pi v squared. Okay, so the next step is I want to divide by 36 pi. And I will tell you, when you do this on your calculator, you're going to need to be careful. You're going to need to enclose this 36 pi in parentheses so the calculator understands that that pi symbol belongs in the denominator. Okay, if you type that in, get something roughly that looks like this. That is not equal to v though, that's equal to v squared. So our final step is to take the square root of both sides. We'll go ahead and round this to 2 places. Now instead of labeling this inches squared though, this is now volume, this would be inches cubed. Okay, inches cubed. You can see on your notes page here that your homework assignment is to do worksheet 6.4. I think you're going to find that most of the problems are very similar to these examples that we did together here on this notes page.